Hi there. So this is the second video in the series of experiments that we have around large language models. The first article/video was about fine-tuning, and we have experimented and analyzed how we can distill new knowledge in existing pre-trained models, open-weight pre-trained models. This video is about testing how well a model knows certain framework. In our case, we're going to be checking out Drupal 10/11, and we built a tool called Nichebench, which basically allows you to run quiz and code generation tests. Not Drupal specific, you can do any of them that you want for targeting any framework, but in my case it's a Drupal specific one, and to see how well do these open weight models perform. Usually, as developers, we tend to use state-of-the-art models like Claude 4 or Cloud Sonnet 4 or GPT-5 or some other state-of-the-art models, because open-weight models usually are underwhelming. But this article is here to cover how underwhelming these models are. So I will dive a little bit into what is Nichebench and how it works. First, so we have two types of tests. First, I want to cover that Nichebench was originally built around deep eval. This is a framework, and it has like really awesome tests there. But I kind of extended this framework, and I built my own CLI tool to have like neater reports. And there are two types of tests that I defined: quiz and code generation. Both of these tests use LLM as a judge in the end, even if the model needs, in case of a quiz, it just needs to select the right choice, A, B, C, D, or E, or F. A lot of models can sometimes do some summary or some reasoning or explain why did they choose a certain like solution. And I don't want to use like regexpert and stuff like this, so we're using just the LLM as a judge to parse through the outputs and say like, oh, we want to use actually F as the chosen answer, and it's a false one or it's a true one. So this is the quiz sample. We have 145 quizzes. Quizzes are different. They're sometimes targeting new APIs in Drupal 11. Sometimes they're targeting Drupal 10 or generic APIs. And basically this allows us to know, gauge how well does a model know like how recent knowledge it is, and how well does it know how to implement certain things. Quizzes are usually having pretty good scores when it comes to large language models. And now the second one is code generation is like way more sophisticated. It has a very complex context and the summary just for us, but it has like a prompt, exactly what we expect from the model to implement. And then there's a judge side. There's a judge checklist. Judge checklist can be like, hey, this model had to implement like these 12 or 15 steps. And sometimes the judge wouldn't know certain like new APIs or new knowledge that there is. So you would put judge notes on some of these things, so the judge doesn't have to go online and look for stuff. So we don't want to provide the judge any tools, but the judge sort of has to know the source of truth, so it can rate properly the model. And this is how it works. There are two tests. I have tested a lot of models when it comes to quiz, because usually quizzes are fast to go through unless it's a reasoning model. Reasoning models take a lot of time to reason about it and then come up with a one-letter answer, right? The dense model, there are non-reasoning ones that are usually way faster to come up with an answer. I mean, you can test it like pretty fast. It's also fairly cheap, because usually the judge only basically gets a little bit of thinking or output, and usually it's a lot of input and almost no output, right? This is the scores. You can check those out on my blog article. I also have access, or give you a link to this one. This is like a spreadsheet with proper scores and how many tests did it pass or fail, stuff like this. So you can also click the link there and read it on your own. And you would usually see that a lot of there are actually some reference models that I use, like the SOTA models, proprietary, Anthropic, or OpenAI, and you would see that they're scoring around 92%. And the closest one that gets to this score is, for example, Qwen 3 Coder, 480 billion parameter model. This one gets 91%. But also there are all other outliers. For example, the GPT OSS 120 billion parameter models gets 90%, just like GPT-5 Mini. What else I want to highlight here? Oh, one of outliers was Pi, or Microsoft PHI 4 14 billion parameter model. It also gets around 80%, which was a little bit shocking to me. And that's pretty much it. So you can see results, some of them like go downhill from here. For example, GPT OSS 20 billion parameter model is around 82%. But you will see the diff is not that big from like model to model. They're usually close to each other. I mean, there are like outliers that go way worse, but anyway. And what I wanted to go, what gives more interesting results are the 12 code generation tests. There are only 12 of them because it usually consumes a lot of tokens to generate like a huge response and to analyze it. And as a reference, GPT-5 at medium thinking capacity gets around 75%. Doesn't mean that it doesn't know well Drupal enough. Maybe my tests are not aligned with it, or maybe I should have used like high performance, or maybe it would score than 80-85%. I'm pretty sure Cloud Sonnet 4 would score around 80-85% as well. But the gap here from the open source open weight models is pretty big. So the closest one that I tested from all of these is GPT OSS 120 billion. It gets 40%. And with the Qwen, the one that was like super high in the previous test, gets 34% here. This one is like at 8-bit precision. But also you will notice pretty interestingly that GPT OSS also gets 20 billion parameter model gets 32 to 35. I mean, first time it scored 35% higher than 32 billion parameter models, higher than even the GLM 4.5, which is like 300 billion parameter model, if I'm not mistaken. So you will see they're scoring not as good, but GPT OSS 20 billion did a really good job. And yeah, so further I dive into analysis, and in comparison between all of these models, and that's pretty much it. You can check out the results, you can test your own frameworks if you want using the same logic. The tests are not public, just as a note. The tests, I didn't want to put them publicly because I want to keep them away from the models or crawlers that then use the data to train the models, so that I can easier test the new or upcoming models. If you want to get access to the tests, feel free to reach out to me. I'll give you access to their private repo. And that's pretty much it. Now maybe the final part is, why am I doing this? Well, for now, this is just for you to know like which models perform better in Drupal. But ideally, I want to select a model so that in a later article, I would fine-tune it to reach almost or better than state-of-the-art models performance when it comes to Drupal. I will try to do it with 20 billion parameter model. I mean, GPT OSS 20 billion kinda is the leading model that I want to pick, even though it kind of lacks proper serialization when it comes to JSONs or YAML or XML. But I still want to try and improve it and see if I can reach like really good numbers. Maybe maybe surpass 60-70% on this test, maybe even surpass 70%. I don't know. This is the goal, to see if we can use small models but niche, fine-tune them on a specific framework domain and see if this is doable. So if you're interested in the results, please check out the blog article, support me on Ko-Fi. This will definitely help me when it comes to fine-tuning, because this will require me to buy 3 GPUs. So I would be very thankful if you consider contributing to my efforts. And yeah, let's stay in touch.